section, we will cover different caching strategies. We will cover these four caching strategies, which is cache aside, read through, write through, and write behind. Let's start with the first one, which is cache aside. In this approach, the application is responsible for managing the cache. That means whenever the application needs some data, it will go to the cache first. And if it finds the data in the cache, that means if this is a cache hit, the cache will return the data back to the application. But in case this is a cache miss, that means the application couldn't find the relevant data in the cache. In that case, the application will read the data from the database and it will also update the cache so that next time when the application needs the same data set, it will get a cache hit. So in this case, the cache is not updated automatically, and for all the cache misses, application is responsible for reading the data from the database and updating the cache. So this kind of a strategy is useful for scenarios where the application fully controls the data updates, when to fetch the data, when to update the cache, and the application manages the cache directly. And notice in this strategy, the cache will not be updated automatically. So this strategy is called cache aside. Let's move on and understand the next strategy, which is read through. In this approach, the cache is responsible for updating itself. Suppose the application on the left needs some data, so it will check the cache first. Now, if it finds the data in the cache, that means if this is a cache hit, then the cache will return the data back to the client. So that is the happy scenario. But in case the requested data is not found in the cache, that means this is a cache miss. In this case, the cache will talk to the database or any other data source such as API. It will fetch the missing data. It will update the cache for the future access, and it will also return the data back to the application. So in this case, in case of a cache miss, it's the responsibility of the cache to find the missing data and update itself and also return the data back to the application or the client. So this is the read-through approach, in which the responsibility of handling the cache misses lies with the cache itself. Read-through approach is good for read-heavy systems where reads are more frequent. So we want cache to handle the cache misses by fetching the data automatically. But it can also increase the overhead of the caching layer, as it has to perform this responsibility. It has to read the data automatically. We will now discuss the next strategy, which is write through. In the write through approach, the data is always up to date in the cache and the database. That means whenever there is an update, the cache and the database are updated synchronously and together. So suppose we have the application which needs some data. So it will check the cache first. If it finds the data in the cache, if this is a cache hit, then the cache can return the data back to the application, back to the client. So this is the cache hit scenario. Now let's say there is a write operation or an update to an existing entry. In that case, that operation goes through the cache, hence the name write through. So the update will be made in the cache, then synchronously to the database. And that makes sure that the cache and the database are always in the sync because they are updated synchronously. In this case, the possibility of returning a stale data is very minimal because all the updates will go through the cache, and so these two entities will always remain in the sync. Now, this strategy is useful for the scenarios where writes are more frequent. This is good for write heavy systems. And the another condition is we want the cache and the database or the original data source to be in sync, and this sync is very critical. In such scenarios, in such use cases, we can use the write through approach. Having said this, we need to be careful about one drawback, which is because this update happens synchronously, it means the cache and the database are updated synchronously. It increases the latency of the write operation. So any client that is making this update has to wait until this operation, this link is completed successfully. So it will have to wait for the time it takes to update the cache, then the time it takes to update the database. So although it solves the problem of consistency between the cache and the database, but it also increases the latency of write operations, which may not be perfect for extremely write heavy systems. So this is the write through approach. And the last strategy we will discuss is write behind. Write behind is similar to the write through. The only difference is the database or the original data source is updated asynchronously. So let's see what do we mean by that. Suppose we again have the same application which needs some data. So it will check the cache first. If it finds the data in the cache, if this is a cache hit, then it gets a successful response back from the cache, a value that it requested. All right. Now let's say there is a write operation or an update to an existing entry. Then in that case, all those updates will be made to the cache first. All right. And the cache can return the successful acknowledgement so that the client doesn't have to wait for longer time. So in this case, the cache is updated immediately. But what about the original data source? What about the database? Well, after some time, after some delay, the cache will write all those changes in a batch to the database. So the database is updated asynchronously in this case. In the write behind approach, because the cache is updated always immediately, in most of the cases, it will always return the up-to-date data. But because the database or the original data source is updated asynchronously in batches, so there might be a latency, there might be short duration of time when the cache and the database are not in sync, because this has to happen, this operation has to happen. Also, because this update happens asynchronously, the client that made these requests, update requests, they don't have to wait for the additional time. So as long as the operation is done in the cache, it gets the acknowledgement. That means the write operation is considered successful as soon as the cache receives the update. So this kind of a strategy is good for extremely write heavy systems which need high write throughput. There is another risk with this approach. Let's say what happens if the cache goes down before this update happens. In that case, all the updates which were waiting to be synced to the original data source might be lost. Different caching solutions solve this problem differently. Let's say by using val, which is write ahead log, or any kind of persistent log that can be replayed in case of any crash. But we need to be very careful about this scenario if we are developing our own solution from scratch. So this is the write behind approach in general. So in this section, we cover different caching strategies: cache aside, read through, write through, and write behind. We understood the use cases, the differences between them, and when to use which caching strategy. Now, this is not an exhaustive list, but these are the most common caching strategies that you will find at other places. So that's all for now. See you in the next video. Thanks for watching.